Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And salam sejahtera. This time, this video is recorded for chapter 1, Valence bond theory. We still are in the chemical bonding, but we moving from the basic concept of chemical bonds and molecular geometry. We move to the another theory to describe the chemical bonding, which is valence bond theory. Okay, in our previous lecture, we cover these three items. We cover about the molecular formula. Every compound has a molecular formula. From the molecular formula, we can draw the Lewis structure. And from the Lewis structure, we can predict the molecular geometry by using VSEPR model. In the VSEPR model, we explain about the electron domain geometry and also molecular geometry. In this lecture, we're gonna to continue to explain the covalent bonding by using another theory. We call it valence bond theory. So, what is the valence bond theory? Valence bond theory is another model. Previously, we're using VSEPR model to predict the geometry of the molecule, but valence bond theory is another model that can be used to explain further the covalent bond using atomic orbital. So in this chapter, we're gonna to talk a lot about atomic orbital that overlapping between two atoms. So what is atomic orbital? Uh, what is atomic orbital? I think during your SPM, matriculation and foundation, if you still remember regarding S, P, D, and also F. This is the atomic orbital we are referring to. Okay, so now we try to explain the formation of covalent bonding by using the overlapping of atomic orbital between two atoms. So the valence bond theory will showing the way of atomic orbital can mix one another to form the covalent bonds. Before this, if you want to explain the bonding, we just using the Lewis structure like this oxygen say is formed between two atoms. Say two this oxygen form double bond. We explain like this. We explain in terms of Lewis structure. We explain in terms of the valence electrons. But in this time, we're going to explain the formation of bonding by using atomic orbital of which atomic orbital that involved in the formation of bonding. Okay. So this is a few example. Is the general or the simplest bonding. We have hydrogen, H2 is between 1s with 1s. Between hydrogen chloride is between s with p orbital, and between chlorine is between p orbital with p orbital. So your task is you should be able to identify which orbital involved in bonding, which orbital involved in bonding, which orbital involved in bonding. In previous lecture, we don't care about the orbital. We just care about the valence electron. We just care how to distribute the valence electron in the bonding. But this time of around, we're gonna to explain further explain further the bonding by using atomic orbital. So every molecule, you have to be able to identify which orbital are involved in the formation of bonding. So we're gonna to go through one by one. All right. So this is the simplest molecule, which is H2, hydrogen. So we know hydrogen. We know hydrogen total electron is 1. So valence electron is supposedly 1 is 1. So this is the valence electrons. 1 valence electron. Total electron of 1. We write the electronic configuration. So we find out the valence electron is 1 valence electron. This is why the energy diagram for this valence electron, because only valence electron involved in the formation of bonding. So we have to focus valence electron. So for the first hydrogen atom, it should be 1s1. This is why this box containing of 1 electron. And same goes to another hydrogen atom is 1s1. So this is why this is 1 hydrogen atom. If we want to draw in terms of atomic orbital, we know the valence electron for the hydrogen is s orbital. So s orbital, it should be round. So this is s orbital of the hydrogen. And also this one is the s orbital of another hydrogen. If you want to form, this is in terms of separated hydrogen atom before the bonding. If you want to form the bonding, so these two s orbital have to overlap. Have to overlap. Have to overlap. So when it's overlap, it forms H2. Ini dia separate lah. This is one H, another H. Form hydrogen, it should overlapping. So this orbital will be all overlap to form chemical bonding. So this is one single bond. Okay. So s orbital with s orbital for the hydrogen. Okay, we look for the another example, hydrogen fluoride. We know hydrogen fluoride from the Lewis structure, it should be like this. Hydrogen, single F. But in the Lewis structure, we cannot tell which orbital is involved in the formation of bonding. Is it s orbital with s orbital, or s orbital with p orbital, or what, s orbital with f orbital? So we don't know. So we have to identify which orbital in each atom involved in the formation of bonding. So we have to draw the energy diagram of valence electron for each atom. We know hydrogen total electron is 1, so electronic configuration it should be 1s1. So valence electron is 1 valence electron. For the fluorine, we know fluorine is dua empat enam lapan. We know fluorine, total number of fluorine is 9. You have to check the periodic table. In every test, quizzes or exam, the periodic table will be given. You don't need to worry. You just check the periodic table. You know what is the total number of total electron for the atom. For the fluorine, total electron is 9, and then you have to write the electronic configuration. 1s2, and then 2s2. After that, it should be 2p. Ini dah 2, 4. So, 9. So, 2p, 5. You kena ingat S maksimum 2, P maximum number of electron is 6, D maximum number of electron is 10. So you have to remember this one. So electronic configuration for the fluorine, total number of electron is 9, 1s2, 2s2, 2p, 5. So the valence electrons is the outermost orbital. So how many valence electron is 7. 2 plus 5, 7 valence electron. And then you have to draw the electronic energy diagram in order to identify which orbital involved in the formation of H with F. Orbital apa yang akan overlap between H dengan F. So kita kena draw the energy diagram and then we can identify. So as we know, hydrogen, the valence electron is 1s1, so 1s1. So this is s orbital will involve. And for the fluorine, we know a 7 valence electron, which are 2s2. This one is full, up and down, 2s2 and 2p5. 2p5. Okay. So 2p5, now because of p orbital is maximum of 6 electrons, so they have to have 3 boxes. So the fluorine, kita kena buat satu-satu lah. We have to fill in the 5 electron one by one. 1, 2, 3, and then 4, So when we done this, we can identify orbital yang mana yang akan terlibat dalam ikatan kimia. Because we know hydrogen will contribute one electron, fluorine will contribute one electron. So the electron should be single, single. Single from hydrogen, single from fluorine. So they will share in order to form the single bonding. So in this case, we know the orbital that involved in the formation of this one is the s orbital with the p orbital. Okay, so p orbital, we know p orbital is Vx, and then we have Vy, and then we have Vz. Okay, so how do we overlap between this s with the p? So before the overlapping, we know hydrogen is one s orbital. So like this. The F, we know the orbital that will be overlapping with the hydrogen is the px orbital. So this is a px orbital. So we have px, we have py, and also we have pz. Don't worry about this one because we only have a px. So this is a px. So the p orbital, if the s orbital is round, the p orbital, regardless of px, py, or pz, is like this. It's like the bowling, 10-pin bowling. It's like a chromosome. Okay. It's in a biology, it's like chromosome. This is the shape of this p orbital, and the px position, py position going up or a bit sengit for the pz position. But for this particular example, the combination of the hydrogen with the fluorine is between s orbital with the px. So when we overlap to form this molecule, hydrogen fluoride, we know it should be between s and p orbital, which is a px. So this is why this is s, this is px. Px in the x position lah. This is the first single atom. All right. So you have to try to do the oxygen. You have to do it by yourself. Okay. We know oxygen. Every time we want to identify, we have to draw the orbital diagram of valence electron. So we have to write the electronic configuration. So oxygen total electron 2, 4, 6, 8. So total electron of oxygen from the periodic table is 8. So the electronic configuration is 1s2, and then 2s2, and then 2p4. 248. 248. So the valence electron should be the outermost orbital is 4 plus 2 is a 6 valence electron. So we draw the orbital diagram for the first oxygen because we know this one The Lewis structure should be like this. And the two lone pair, and they have another two lone pair. So in this valence bond theory, we try to identify which orbital involved in the formation of double bonding, which orbital, because valence bond theory is showing the overlapping of atomic orbital. So you have to identify which orbital involved in the overlapping of orbital to form the chemical bond. So we know from the electronic configuration, we know the first oxygen is 2s2. So 2s2. The P is 2p4. So P4. So we will write 1, 2, 3, 4. Same goes to another oxygen. So S2 full and also 2p4. 1, 2, 3, 4. So when we done this, we can identify which orbital will overlap with which orbital. So this is single. So we know this single should share with another single to form one chemical bonding. Same goes to this one. This single should share with another single. This is why we need a single electron orbital. So this single will couple with this one to form the first bond. So another single, which is this one, should be coupled with this one to form the single bond. So this is a px py. This one is a px py. Remember this. This is a px. This is a py. This is a pz. X and y, and also z. Okay. In order to draw, this is the after bonding. This is a before bonding. We know before bonding, oxygen, it should have px and py. Px, and it should have py, because p orbital is look like the pin bowling or chromosome. Another oxygen, the same identical oxygen, px, and also py. So we have to overlap this one in order to form the O2, oxygen. So we bring it a bit closer. So this is the oxygen. This is the oxygen. We know this px will overlap with another px. And then we know this py will overlap with another PY. Because we cannot overlap the PY closely, so we should use the imaginary line, the dotted line, to show this PY overlapping. This PY are overlapping. Okay. Okay. We go another example, which is nitrogen. We know the Lewis structure of nitrogen is like this: triple bonding, and they have lone pair. We know, we're confident enough. We know how to draw this. So our task, we try to identify which orbital involved in the formation of triple bonding. Again, you should draw the orbital diagram of valence electron for each atom. Then you can get the answer which orbital involve the triple bonding. We know nitrogen is for 7, total electron of 7 from the valence and from the predictable. So if you want to write the electronic configuration, it should be 1s2 and 2s2 and then 2p3, because total only 7. That's why the valence electron is 5 valence electron. So we complete this diagram. We know each nitrogen is 2s2 according to this one, 2s2. We know 2p is a 2p3. So it's 1, 2, 3. 7 goes to here is 2s2, 2, and then this one is 2p3. So we know which orbital now are involved in the formation of triple bonding. This px with px, this py with py, this pz with pz. Px with px, py with py, and also pz with pz. So before the bonding, we can draw like this. We have nitrogen separately, like this, nitrogen and nitrogen. So we know nitrogen, they have px, py, and pz. So this is a px, this is a px, and then we also have to draw the py. This is a py. You can draw better than me because I'm using the mouse. Py and py, and also you draw the pz in the z-axis. So we have to bring it close together to overlap each other to form the N triple N. So just bring it together like this. So we know this Px will overlap to form Px to form one of the bonding, and then Py also overlap with the Py. We connect them with the dotted line to show the overlapping. Yes. Py with Py. In the last one, we have Pz with pz and the z axis. So we also connect the pz with pz with the dotted line. So yeah, it's like that. So we should identify which orbital is involved by drawing the orbital diagram. In order to draw the orbital diagram, this orbital diagram, you should be able to write the electronic configuration from the total electron for that particular atom, and then identify the valence electron, and then you can draw the orbital diagram of valence electron. From there, you should identify which orbital are single, because only the single can partner with the single to form one chemical bonding. Single with single, single with single, single with single. The double one is already occupied. It cannot form the chemical bonding. Yeah. All right. So the space, the electron domain that formed by overlapping of atomic orbital between two atoms only has two valence electrons with opposite spin up and also spin down. We see this one between S with S for the hydrogen is spin up, spin down. The space of the electron domain where we form the overlapping area. Within the overlapping area, it has two valence electrons up and down. Here also the overlapping area. It has electron, two valence electron up and down, and here too they have electron up and down. Okay, so I think for this video is enough until here. We're gonna to continue on the next video on the hybridization. So I just want to recap. It is it's a simple one. This is a valence bond theory. Is the extension from the previous lecture. Is another model that we use to explain further the covalent bonding by using the valence bond theory. So in the valence bond theory, we're gonna to use the atomic orbital that overlapping between the two atoms to show the formation of bonding. In the Lewis structure, we use the electrons. In the valence bond theory, the overlapping between two atoms we show using the atomic orbital. We have SPDF. So it's our task to identify which orbital is involved in the chemical bonding. So it shows the way of atomic orbital can mix one another to form another covalent bonding. So this is a few example. S with S, S with P, P with P. Okay. So yeah, we done from the simplest compound, hydrogen, and then we identify for the formation of hydrogen, it should be overlapping between S and S from the energy valence electron. From the energy valence electron, how to draw this? This you have to write the electronic configuration and identify the valence electrons. Same goes to another example, hydrogen fluoride. We draw the energy diagram of valence electron, and then after that we can tell which orbital will be single involved in the formation of chemical bonding. So in order to form the hydrogen chloride, it should be the overlapping of s orbital, the round shape, with the px orbital with the like the pinballing or chromosome shape. So when we goes to the oxygen, we know from the Lewis structure is oxygen double bond oxygen. So after we write or we draw the orbital diagram, we know in order to form the double bonding, it should be px with px and also py and py. This is the way of atomic overlapping. Last but not least, nitrogen. From the Lewis structure, we know nitrogen is triple bonding. So in the valence bond theory, we should identify within the triple bonding which orbital are involved. So after we draw the valence orbital diagram of valence electron, we find out the p orbital px, py, pz are single. Three of them are single, so they are couple each other, px with px, py with py, pz and pz, in order to form the nitrogen triple bonding. So we just overlap the nitrogen with another nitrogen. So this is the diagram for the nitrogen. So this one is show the overlapping area. We call it electron domain or a space domain, where we can find out the two valence electron with spin up, spin down. If in the overlapping area, spin up, spin down, and also spin up, spin down. Okay. So that's it for this record video. I will continue the hybridization of atomic orbital on the next video. All right. So thank you very much. See you again on the next video.